Hi, welcome to the first lesson on the scientific method. I'm Wendy Nofke and I'll be giving you your presentation today. So first I'd like to start out with a quote from Sir Isaac Newton. If I have seen a little further, it is by standing on the shoulders of giants. This is a great quote to go with science because what this quote tells us is that even though we are taking steps forward, we wouldn't be where we are today without the work of those who came before us. And in science, we are continually building on the knowledge of those who have done their research before us. So what exactly is science? Science is a study and the comprehension of natural phenomena. Something very similar is technology, which is the application of science. In our society, these two things tend to go hand in hand. We will use the knowledge gained in science to help apply things to make our world more convenient through technology. Scientific skepticism is questioning claims rather than accepting them based on faith and anecdotes. This is an important attitude to have when approaching things in science. If we question things, we're more likely to find the mistakes or the errors in them before we make big decisions, including those errors and mistakes. When we look at things in science, we also have some misunderstandings about how accurate and well-researched the information is. What we start out with is a hypothesis. It's a proposed explanation made on the basis of the limited evidence as a starting point for further investigation. It's basically we look at what is going on and we say, this is something going on that I don't fully understand. This is what I think is going on and I would like to test it. The hypothesis has the most room for error of these three terms because it is not tested as much. However, the hypothesis does not come out of nowhere. There is a lot of background knowledge that goes into creating a good scientific hypothesis. The scientific theory is a well-substantiated explanation of some of the aspects of the natural world that are acquired through the scientific method and then repeatedly confirmed through observation and experimentation. A lot of times in our everyday language, we use the term theory to imply a lot of doubt or that we're not sure if something is accurate. But with the scientific theory, we're pretty sure it's accurate at that point. We have a lot of evidence supporting the accuracy of it. The scientific law is a statement based on repeated experimental observations that describe some aspect of the natural world. This is a statement that we're a little bit more secure in the accuracy of it. The scientific law always applies under the same conditions, and it applies that there is a causal relationship involving the elements. And then there are some questions that are just not answered by science. Things regarding beliefs or religion. We have no way of being able to test or prove a lot of these things. And if we can't use the scientific method to be able to examine something, we're not able to scientifically answer the questions. This is also going to include the supernatural, moral issues, and the meaning of life. After we gather our information in science, we need to use some reasoning to try and interpret it. There's deductive reasoning that determines a single fact from a general statement. This is only as accurate as the statement. With inductive reasoning, we determine a general statement from several individual facts. In science, we're better off to use deductive reasoning whenever possible. Inductive reasoning has a couple of flaws that don't make it ideal for the scientific method. With inductive reasoning, the truth of the reason does not guarantee the truth of the conclusion. Also, inductive reasoning involves reaching conclusions about things that were not actually observed. So what happens when we find disagreement in the predictions of long-standing theories? We have a couple examples here. First is with classical mechanics. Newton's law is accurate for most of human experience. So Newton's law explains gravity and what goes on with motion. There's also the relativistic mechanics, which use Einstein's law. These are also accurate for the human experience, but they're accurate beyond the human experience. Newton's laws are not accurate in space. They're not accurate at very high speeds, such as the speed of light, where Einstein's laws actually account for those things, so they're slightly more accurate. A lot of times we have some misconceptions about who scientists are and what they do. One of the biggest misconceptions about scientists is that they spend all their time in the lab. Scientists actually come from many different backgrounds. Scientists come from all over the world, include both males and females, and scientists have a lot of variety of interests. Scientists can do many different things for work and work in many different occupations. One thing that is important is a scientist must be good at communicating and cooperating with many other professions, since most scientists do not work alone. There are several different branches of science. Just a few examples here. Biology studies living things. Physics is going to be the study of how things work. Chemistry is going to study matter. Astronomy studies what's in space, the stars. Ecology studies the environment. Geology, the earth. Taxonomy studies naming. And then genetics is a relatively new field, looking at heritable information. These are just a few examples of science and how we can use them.